This video is on exponents and basic properties of exponents, and this is out of Blitzer's pre-calculus textbook, specifically section P2. In later videos we will discuss properties of exponents and simplify exponential expressions, and then later on talk about scientific notation too. Okay, so first of all, I have two equations down below here, and I want to represent them in a different way, in a more condensed form. Okay, so how can I do that? Well, this says I add 3 5 times to get 15. Okay, so what I'm saying is that if I have 3, I have 5 groups of 3, and if I add that together, that's 15. So really, the shorter condensed version of this equation is to say it's 5 times 3, which is 15. Now down below here, this is all one group. I don't have it separated by addition. I have multiplication in between the 3's. Okay, so what I'm going to have is I can write this as one group, but then I have 3 occurring, and I want to represent this multiplication by 3 5 times. And so to do that, I actually use an exponent. Okay, so it's one group of 5 3's being multiplied together, and this is 243. Okay, so the idea of exponents really is that exponents represent repeated multiplication. Okay, so let's look at the difference between these two expressions. 3 to the third, okay, well, what does that mean? If I write this out, this is, I have 3 times 3 times 3, okay, that's this chunk, and then I have an addition sign, and then 3 to the fourth, I can represent that as 3 times 3 times 3 times 3, okay, and so this, I can't expand it out any further, and so this I would just have to evaluate it. 3 to the third is 27, and then 3 to the fourth, or if we do this multiplication, this is 9 times 9, essentially, if we look at these two, and so this is 81, and remember the equal signs. Okay, and then if we add this all together, what do I get? 108. Okay, so that's that answer. And now here, what this expression is saying, this is very different. So this, again, I'm going to write it out. So 3 times 3 times 3 for 3 to the third. And then 3 to the fourth, I have a multiplication sign in between here. 3 to the fourth, I have 3 times 3 times 3 times 3. Okay, that's 3 to the fourth. But now I have the same operation throughout. So I can really just get rid of the parentheses by associativity of multiplication. I can rewrite it as this. So I have 3, let's see, this is 5, 6, 7, okay? And so another way I could write that is 3, and then I have 7 3's being multiplied together, so that becomes the exponent. Okay, so what was the relationship that I used here? Well, I represented 3 3's being multiplied together here, 4 3's being multiplied together here, and what was the end product? So I got out 3 to the 7th. Well, I could have just done that by looking at the exponents and adding them, okay? Because 3 plus 4 is 7. So in general, if we have multiplication, if we have same base exponentials, I can add their exponents. So, for example, down here, the general rule is if I have b to the mth power times, and then again, remember that this is the operation of multiplication in between here, just for clarity. B to the n power, all I have to do is add the exponents. Okay, now similarly, there's going to be a rule with division, but let's go ahead and explore that. So here, what does 3 to the fifth mean? That means I have 5 3's being multiplied together in the numerator. Okay, in the denominator, 3 squared. That means I have 2 of them. Okay, well, there's two threes in common in both, so I can scratch both of those. And what am I left with? 3 times 3 times 3. Okay, so that's, as an exponential expression, 3 to the third power. Okay, you may recognize the pattern here, but for the sake of clarity, let's go through another one. 3 to the third, that's 3 times 3 times 3 all over. And now I have 8 3's, so this is 1, 2, 3, 4, 5, 6, 7, 8. And so again, I have at least 3 threes in common, so I can scratch 3 of them. And what am I left with? I'm left with 1 over, and then I have 5 threes in the denominator. So this is 1 over 3 to the 5th. Okay, so what did I do between the expressions? Well, I can write it out and simplify it. That's all good. But up here, well, to get 3, I just subtracted the exponents. Similarly here, I ended up subtracting the exponents, but the larger of the exponents is in the denominator, so that's where my result went. Okay. In general, again, same base exponentials, you'd take their difference. Okay. And now this case, we'll talk about another rule shortly that will allow us to rewrite it in a different way. So if we were to subtract these, again up here, this, I'm just going to come over here and write it. If I subtract them according to this rule, I would get 3 to the minus 5, right? It's because I do 3 minus 8. 3 minus 8 is a negative 5. Okay? And then we'll talk about why we ended up having it in the denominator shortly. Okay? Now, for repeated multiplication, what does this say? This says I have 4 3 squareds all multiplied together. So this is equal to 3 squared times 3 squared times 3 squared times 3 squared. And so in total, this is 2 3's, 2 more, 2 more, 2 more. How many total? That's 3 to the 8th. Okay, so I ended up, remember the sum rule, I add, for same base exponentials, I add the exponents. So this is 2 plus 2 plus 2 plus 2, or 8. Okay, so again, we can generalize that rule. And if we have a product, or if we have a power to a power, we multiply the exponents. Okay, 2 times 4 was 8. All right, and then here, now this one, I want to write this out carefully. So again, writing this out, this means I have 3 2x's all multiplied together. So this is 2x times 2x times 2x, okay? But now due to, remember, multiplication is commutative, meaning I can rearrange this at will. So I can put all the 2's together, and I can put all, let's undo that. And again, and I can put all the x's together, and I have another x, and I have another x. And so what I have in the end is I can rewrite this as 2 cubed times, and then x cubed. Okay, I can group them all, rewrite them, and then we can simplify this from here. But the idea that I want to drive home is that we can actually distribute the exponent to each term. Okay, so remember to do that rule. And then now here, this is a list of all the rules that we more or less talked about. The power rule for a quotient is essentially the same thing as a power rule for a product. Just 1 over b is a fraction, so b here would be a fraction. The other thing that we kind of glossed over were these 2 rules. So these are definitions. So if we have b to a negative n power in the numerator, so actually you could write it almost as over 1. It's actually a positive exponent if it's in the denominator. Okay, so remember that. And then anything to the 0 power is 1. That's another definition. So these are the basic properties of exponents and how they are developed. And in the next video, we'll talk about simplifying exponential expressions using these properties.